I'm gonna see if I can do this lab standing up, basically because the entire lab kind of looks like this picture. So if I kind of do it while you look at the picture, it might make some sense. So take your sodium chloride, which hopefully you have at home, get a spoon. I got a spoon back here behind the whiteboard. I'm just gonna take a nice, maybe a heaping teaspoon, and bam, drop it in. You know the deal. It takes non-conductive, relatively non-conductive H2O water, makes it very conductive. Change the electrical properties of a liquid just by dissolving a soluble compound in it. And you want to do it obviously till it clears up. This is cloudy, but I'll let it go for the moment in the spirit of time. Okay, so here's the tricky part. Follow the picture closely in the launch right up. But you have your copper metal, which we can use a penny for. The copper metal is attached to the long side of the LED. So there's a short side and a long side. This side on over here is the long side, and then the other one goes to the short side. So the penny is connected to the longer side, and then the shorter side goes into the negative terminal of the battery. Then out of the positive terminal of the battery, you connect it to another metal. So magnesium here, but then you can change it with aluminum or swap it out with iron. The key thing is to keep the penny, the copper, always at the same side. And then the next thing to do is simply stick both into your electrolytes. Let's see if I can do this one hand while standing up and see what happens. And you don't want the iron tip of the alligator clip to get into the water, because that iron metal will change your, and I don't know if you can see this, but the LED is on, it's off. Let me turn out the lights and try it. Turn out most of the lights. So I kind of got this lined up. It's actually kind of cool. So I'm just sticking them in. Bam. Amazing. So with the copper, coated penny, magnesium, and a little bit of salt water, I've created enough electricity to light up this LED. You'll compare this with keep the copper penny there, but swap out aluminum and then iron at this electrode. And I'll be curious to see what your results are. And then again, whatever they are, we're gonna have to sort of make some sense of it. All right, see you next video.